Welcome once again to my YouTube channel. Today we are taking a topic from physics, equilibrium of forces. A body is said to be in equilibrium when the net force acting on that very body is equal to zero. That is when the resultant forces equals to zero. The forward and the backward forces summed together gives you zero. When force coming from the forward side balances the one coming from the backward side, such a body is in equilibrium. Or when the force acting from the upside balance the one coming from the downside, such a body is in equilibrium. Or when the net force, that's the total forces acting on that very body, is equal to zero, such a body is said to be in equilibrium. Hence, for a body to be in equilibrium, it is either that the body is not moving or not rotating. Hence, the body will be at rest. Or if the body is moving, it moves along a straight path with a constant speed. Or if rotating, it rotates with a constant angular speed. Such a body is said to be in equilibrium. Then we have two major types of equilibrium. We have static equilibrium and the dynamic equilibrium. A body is said to be in a static equilibrium when the body is not moving. That means the body is at rest. But dynamic equilibrium or kinetic equilibrium as well, when the body is in motion and it moves with a constant uniform speed. Or if the body is rotating, it rotates with a constant angular velocity. Such a body is said to be in dynamic equilibrium. Okay? So, we are going to look into conditions necessary for a body to be in equilibrium. One, that's the conditions of a body in equilibrium. One, we have the net forces acting on that very body. It must be equal to zero. Okay? If the resultant forces acting on that very body is equal to zero, such a body is said to be in equilibrium. Then again, if the horizontal component of forces acting on that very body is equal to zero, such a body is said to be in equilibrium. So Fs means what? The horizontal component forces. If the sum of all the horizontal component forces equals to zero, such a body is said to be in equilibrium. Then number three, the vertical component of forces acting on that very body. If the vertical component of forces acting on that very body is equal to zero, such a body is said to be in equilibrium. So Fy means what? The vertical component of forces acting on that very body. And then lastly, we have moments of a force being equal to zero. The moment of a force, although we said the moment of a force is the turning effect of the force. So if the total moment, both clockwise and anti-clockwise, sum together gives you zero, such a body is said to be in equilibrium. So this means the moment of a force. So the moment of force is equal to zero, the body is said to be in equilibrium. Now today we are going to look on the parts of equilibrium, which is equilibrium of concurrent forces. The equilibrium of concurrent forces. So when we talk about concurrent forces, we said that the concurrent forces are forces that act from a point. Take for example, we have vertical horizontal components. Here is vertical components, horizontal components. A force might act from here. So we have F1 through angle theta 1. Force might act from here. Maybe we have F2 through angle theta 2. Then force might act from here. Maybe F3 through angle theta 3. Maybe we still have a force here. F4 acting through angle theta 4. Now, all these forces act from this very point. Hence, the four forces are said to be concurrent. So when forces act from a point, we term it concurrent what? Forces. So we are going to look into equilibrium of concurrent forces. Now, for these very concurrent forces, if you want to get any of the given, maybe you are asked to find F1, F2, F3, or even the angle of inclination, such equilibrium of forces could be applied. Once you've mastered all the conditions, you can use any of them. Take, for instance, with this very diagram, we can just take the vertical component of forces, the vertical component of forces. Like here now, the vertical component of forces, that means we have to resolve F1, F2, F3, F4 along the vertical. So once you have resolved them, you get the what? The vertical component of forces. And once you sum all of them together, it must be equal to 0. Okay? Then again, you work on the horizontal component of forces. Then once you have gotten all the horizontal forces, then you sum it to 0, it gives you whatever thing they are asking you. So like I said, equilibrium of concurrent forces is the equilibrium of forces that act from a point. Okay, we have question on the board. It reads, in the diagram above, the particle is in equilibrium. Find the values of P and the Q. So to solve this question now, we have to resolve each and every of the forces into vertical and horizontal components. We've talked about resolution of vectors, so if you have not watched that, go back and watch it so that it will help you to resolve such a vector. Okay, so to resolve this very vector now, we have the vertical and the horizontal components of forces. And you remember, under the vertical, we said anything here is what? Is positive, right? Then the component here is negative y-axis. The component here is positive x-axis, while the component here is negative x-axis. Now we have three forces acting at this very point. We have force P, we have force 20 Newton, and we have force Q. All of them act from this very point. Now, the vector or the force Q is already resolved. Look at, we have Q here. The Q is located along the vertical, so we are not resolving it. So the Q has no horizontal components. Now, coming to 20 Newton, you see that the 20 Newton lies on the horizontal Newton as well as on the vertical axis. So it lies on the horizontal components and what? The vertical components. So to resolve that, we are going to split this 20 Newton along the horizontal and along the vertical axis. So if you bring 20 Newton along the horizontal, we have angle in between. Hence, we are taking cosine of 20 degrees. So if you resolve it here, you see that here now becomes what? 20 cos 30 degrees. So that's the 20 Newton resolved along the what? Horizontal. If you resolve it to the vertical, so you have here to be 20 sine 30 degrees. Now I have splitted this 20 Newton such that one along the horizontal and the other along the vertical. That is resolution of vector. Go back to our previous class. You are going to learn this well. Okay, coming to P Newton, we are going to resolve P Newton to the horizontal as well as to the vertical. So when you resolve P to the horizontal, then it becomes P cos 60 because of the angle in between. So here we are going to have here to be P cos 60 degrees. Then again, we resolve it to the vertical. So if you resolve it to the vertical, it now becomes P sine 60 degrees. So looking at this, we have the forces acting downwards to be P sine 60 and 20 sine 30. Then the one acting upward, we have Q. Okay? The same thing is applicable here. The force acting on the left side of x-axis is P cos 60, while the one acting at the right hand side is 20 cos 30. Now, following the net forces, like I said, the net forces must be equal to 0. That is, horizontal component of forces must be 0. Vertical component of forces must be 0. Now, for the horizontal component of forces, we have this P cos 60 here, while we have 20 cos 30. Okay? So, horizontally, so we have 20 cos 30 plus minus B cos 30 must give you what? 0. Once the body is in equilibrium. So in that case, to simplify it at ease, we just say 20 cos 30 is equal to P cos 60. Just that if you add both of them together and equate it to 0, then this one acts in the negative direction. So it must be what? Negative P cos 60. Then 20 cos 30 acts in the positive direction. So if you are adding both of them together, it will be equivalent, saying that the right hand side is equal to the left hand side value. Okay? Because the sum of both will give you 0. So if sum of both will give you 0, then if one crosses equality sign, it balances. So in that case, 20 cos 30 must be equal to what? P cos 60. So horizontally, P cos 60 must be equal to 20 cos 30 degrees. Okay? So to get the value of P, so P will now be, divide both sides by cos 60, it gives you 20 cos 30 divided by cos 60. So what will be the value of P? We have 20 cos 30 is root 3 over 2. Then cos 60 is half. So we have P to be 20 divided by 2, we give 10 root 3, then all divided by half. So if you divide it by half, 10 root 3 divided by half, then it will give you 10 root 3 times 2 over 1, which will give 20 root 3 Newton. So we've got the value of P. Then let's look into vertical component. So vertically, we have the vertical. The one up is Q, the downward force is P sine 60, 20 sine 30. Okay? So resolving vertically, the one up must be equal to the downward side because the body is in equilibrium. Okay? So we have Q must be equal to P sine 60 plus 20 sine 30. Okay? So what will be the value of Q? Q will now be P, of course, we've got the value of P as 20 root 3. So we do the substitution immediately. 20 root 3 times sine 60 we give what? Root 3 over 2. Then plus, we have 20 sine 30 we give half. Okay? So here we have that Q is equal to, simplifying this, 2 will cancel itself. 2 will cancel 20, we have 10. So we have 10, root 3 times root 3, we give 3, okay? Plus 20 times half, we give 10. So what will be the value of Q? 10 times 3, we give 30, plus 10. So the value of Q will now be 30 plus 10, which is what? 40 Newton. So we've got the value of Q. Let's take another exercise. Okay, so we have another question on the board. The question reads, if the above system is in equilibrium, what are the values of theta and the F? Then looking at this, we have three forces, 20 Newton, F1 Newton, and 40 Newton. Now these three forces act on a body at this very position, at the center here. Now, we need to resolve 40 Newton because the 40 Newton has both vertical and the horizontal component. 20 Newton has only vertical component. It has no horizontal component. Reason is because it lies on the vertical component. Then F Newton has only horizontal component. There is no vertical component. Reason is because it lies on the horizontal component. So in order to resolve this very 40 Newton, you need to bring this very angle theta to the center. So in doing that, you have this. Then by alternate angle, angle here must be equal to angle here. So in that case, you've brought that very theta to the center. Now, to resolve the 40 Newton, we have the vertical component, horizontal component. So the vertical component of 40 Newton, bringing it to the vertical, you have the angle in between. Hence, it will be cos. So we have 40 cos theta. Then resolving it to the horizontal, because of this very angle, not in between the horizontal and the force itself, you sine. So here we are going to have 40 sine theta. Okay, then we've resolved the what? The vector. That means we've splitted the what? The vector. So here now we have 20 Newton. Then here we have force. So we've got all the forces. Now, in order to solve for the value of theta and the F, maybe we consider the vertical and the horizontal separately. We said vertically, then the force at the upper side it must be equal to the force at the downward side. Reason, when you take the sum of the two forces, it must give you 0 because the body is in equilibrium. And remember, this one is in a positive direction, this one is in a negative direction. So if you add it together, it will now be 40 cos theta, right? Minus 20, which will now be equal to 0. So here we have 40 cos theta is equal to 20. So dividing both sides by 40, divide by 40, divide by 40, this will cancel out. You now have cos theta equal to 20 divided by 40 is half. And if cos theta is equal to half, then the theta now becomes the cos inverse of half. Okay? So the cos inverse of half will give us what? 60. So we have theta to be 60 degrees. Now we've got the angle theta. So we look into horizontal components. So horizontally, then we have the F equal to what? 40 sine theta. So the right hand side force equal to the left hand side force. So we have F equal to 40 sine theta. Okay? So F here will now be equal to 40 sine 60 because theta is 60. Then we have F to be 40. Sine 60 is what? Root 3 over 2. So 40 will now be divided by 2. Then we are going to have 20 root 3 Newton. And that answers the question of this very one. So if what we did was able to impress someone out there, do subscribe, share, and turn on notification for others to learn as well. See you on the next class.